All right, we're back with the next part of our lessons, dividing rational expressions. So we first are going to do the same thing that we did with multiplication as well as simplifying. We are going to factor everything, factor numerator and denominator. Then here's a new step. We're going to rewrite the division as multiplying by the reciprocal of the second fraction. So the first expression stays the same, change to multiplication, and then we're going to flip that second fraction upside down. And again, in our next steps, we can multiply numerators together, then denominators together, and then we can reduce those, crossing out those common factors, or we could cross out the common factors and then reduce. All right, so we've got a few. Let's practice them. Let's see where we go. Our first example is x cubed plus 8 over x minus 2 divided by x squared minus 2x plus 4 over x squared minus 4x plus 4. Okay, so I've actually kind of changed the order. I like to take care of the reciprocal part first. So let's just flip that second fraction upside down, and then we can factor everything. So the first expression, x cubed plus 8, that is one of the cube functions. That is the sum of cubes, and that guy has its own pattern. So for the sum of cubes, x cubed plus 8, you take the cubed root of the first term, same sign, and the cubed root of the second term. Okay? Then to get the next set of factors, I'm going to square the first term, which is x. I'm going to square that. I'm going to multiply the two terms together to give me a 2x, but I have to change the sign. And then I'm going to square that last term, which will give me a positive 4. Okay, so x cubed plus 8 turns into x plus 2 multiplied by the quantity of x squared minus 2x plus 4. Okay, cool. Then denominator, the first one is good. After that, we need to look at the numerator of the second expression. So x squared minus 4x plus 4. I'm going to do a times c, 1 times 4 is 4. What multiplies to 4 and adds to that middle term negative 4? Okay, well I can do 1 and 4 or 2 and 2. Let's do 2 and 2. 2 multiplied by 2 is 4, but adds to positive, so I need a negative 2 and a negative 2. Cool. So those will give me the factors of that numerator. Now if we try the factors of the denominator, they're not going to reduce. But guys, take a quick little peek. What did we get for factors of that first thing we did? We got an x squared minus 2x plus 4 for part of the factor as the x cubed plus 8. So those are going to reduce. I don't even have to worry about it. Awesome. Okay, so let's write it all out in factored form. Okay, make sure you got that. Okay, now I'm not writing this mess again. No way. I'm going to go ahead and start reducing and multiply whatever is left. So this is me doing it out of the order that we originally wrote. We have that common factor of that x squared minus 2x plus 4. We're going to reduce that guy. Oh, there's our domain restriction. And then we're also going to look to see, is there anything else? Well, I do have an x minus 2 in both numerator and denominator of the different fractions, but they're in the same places. Or excuse me, it's the same factor. There we go. So then in the numerator, all I have left is an x plus 2 multiplied by an x minus 2 and a big giant 1 in the denominator. So that is my final answer, x plus 2 multiplied by x minus 2. We are all done with this one. Now, if y'all want to be fancy, you can multiply this back together and it'll give you x squared minus 4, that difference of 2 squares, but you can leave it in factored form as well. Now, I did take a little side note. I forgot to do the domain restriction, set that x minus 2 factor equal to 0, which just gives us 2 as the domain restriction. And again, we don't have to worry about the other denominator's factor, x squared minus 2x plus 4, because that one would give us complex solutions. So we don't have to worry about those as domain restrictions. Okay, let's continue on. That one was a doozy. That's a tough one to start with. Second example, x squared minus 2x minus 8 over x squared minus 9 divided by, the last term is pretty easy, x minus 4 over x plus 3. Okay, first step, multiply by the reciprocal. Flip that second fraction upside down on its head. Now go through and factor. Here we go. Numerator, x squared minus 2x minus 8. What multiplies to negative 8 and adds to negative 2? That's right, a negative 4 and a positive 2. So those factors are x minus 4 and x plus 2. That's the first fraction's numerator. X squared minus 9, that's a difference of two squares. We got those down pat. We don't have to do any work for that. That's just an x plus a 3 and an x minus a 3. Cool. And when we look at the terms in the second expression, x plus 3 over x minus 4, there's nothing to reduce with those. I can't factor anything out other than 1. Cool, I'm done factoring. So here are all of my factors. The first fraction had to have numerator and denominator factored. The second fraction did not. Now we can reduce. Oh, nope, we need to do excluded values. Take everything in the denominator, the x plus 3, the x minus 3, and the x minus 4. So the x plus 3 equal to 0, the x minus 3 equal to 0, and the x minus 4 equal to 0 to give us our domain restrictions of negative 3, positive 3, and positive 4. Okay, now we can reduce. What's the common factors that we see? That's right, x minus 4 is in numerator and denominator of everything. Cool. And we also have the quantity of x plus 3 as a common factor. Reduce those guys. And what we're left with is an x plus 2 in the numerator and an x minus 3 in the denominator. Multiplied by a big giant 1, so that's what it is. There's your answer. You're all done. That one was a little bit nicer. And we're really getting the hang of this, that factoring and reducing all of our terms. You guys are powering through. Great work. Oh my goodness, we got a big one. In the numerator of our first expression for this last example, this is a polynomial raised to the third power. So that is a cubic polynomial. We need to factor using our grouping method for that one. For the denominator of the first fraction, that's a regular trinomial, so we'll do the little x thing. And then I'm seeing a difference of two squares in the numerator of the second term, and then another trinomial for the denominator of the second term. Okay. Let's first multiply by the reciprocal. So keep everything, the first part the same, change the multiplication, flip that second fraction upside down on its head. Okay, now let's get to factoring. This is going to be a little bit. Okay, let's take care of the difference of two squares first. So the x squared minus 4, remember take your square roots. That'll be a plus 2 and a minus 2, so x plus 2, x minus 2. Okay, that one's done. Get that out of the way. We're really good with our trinomials, so let's look at those next. We will do this guy over here, x squared plus 8x plus 15. So what multiplies to 15 and adds to 8? So that'll be a positive 5 and a positive 3 with x's on the top. So those factors are x plus 5 and x plus 3. Okay, so we took care of everything for the second expression. In the denominator of the first expression, x squared minus 2x minus 15. So kind of similar to the one that we just did. In this case, we're going to look to see what multiplies to negative 15 and adds to negative 2. I can still use 5 and 3 as the values, but I need a positive, I need a negative 5. Whoopsies. We need negative 5 plus 3, because negative 5 plus 3 is negative 2, and negative 5 multiplied by 3 is the negative 15. Cool. So put x's on the top. And this denominator is an x minus 5 multiplied by an x plus 3. Okay, so that leaves the grouping one to do. We have x cubed plus x squared minus 4x minus 4. When we're grouping, We are looking for the GCF of the first two terms. That GCF is x squared, and it leaves me with an x plus 1. Then we look at the GCF of the back two terms. Now you might have to rearrange, but in this case we didn't have to. So the GCF of the back two terms, they're both divisible by 4, but they're both negative. So let's factor out a negative 4. When I divide both terms by negative 4, I'll get a positive x and a positive 1. Okay, so now we rearrange the factors. The GCFs that factored out x squared minus 4 become one factor. And then I have another one, that same identical factor, the x plus 1. Those are our two factors. All right, did you catch it? Did you see? The x squared minus 4, that's another difference of two squares. So we can take this one step farther. We can write x plus 2 and x minus 2 with the x plus 1. That is as simplified as you can get for that expression. Okay, and there it is, all written out. Okay, now start looking around. Do you have any common factors within the same fraction? Like in this first fraction, do you have anything you can reduce? Or in the second fraction, do you have anything you can reduce? Okay, we don't, so we're going to have to crisscross and look around between the two. What do I have in the same in the numerator of the first as the denominator in the second? That's right, we got excluded values, there they are. We have x plus 2 as a common factor. We have x minus 2's as a common factor. All right, I don't have an x plus 1 except for in that one spot in the numerator. In the next part, we have x plus 3 in the denominator of the first and numerator of the second, so that reduces. And the x plus 5 and minus 5 aren't identical twins, we can't reduce them. So that leaves us with an x plus 1 in the numerator multiplied by an x plus 5. And then I just have that x minus 5 in the denominator. Nothing else can be reduced. That is our final answer. Okay, and you'll notice I forgot again to go through those domain restrictions. So we take everything that we have in the denominator. The x plus 3, set it equal to 0. The x minus 5, set it equal to 0. The x plus 2 and the x minus 2, set each of those equal to 0 to get all of the domain restrictions. Great job. That is our last one for this set. Whew, that was a doozy as well. Thanks, guys. Make sure you are popping in for help if you need it.